everyone, welcome to 4sidestv with me Anjali. The Aditya L1 spacecraft is embarking on a remarkable 110-day journey through space, marking one of the longest expeditions for an Indian spacecraft since the Mars mission in 2013 and 2014. To ensure its precise trajectory, a trajectory correction maneuver was necessary. Let's explore the significance of this maneuver and why it was crucial for the success of the mission. Here's a special report from 4sidestv. The Indian Space Research Organization, that is ISRO, announced on Sunday, that is October 8th, that it had conducted a trajectory correction maneuver, that is TCM, for its spacecraft Aditya L1 in order to ensure its successful arrival at the Sun-Earth Lagrangian point 1. Aditya L1 is embarking on a 110-day space journey, which is one of the longest expeditions for an Indian spacecraft since the Mars mission of 2013 to 2014. ISRO scientists had previously mentioned the necessity of a TCM for Aditya L1 shortly after the spacecraft began its journey towards the L1 point on September 19th. Unlike lunar missions, which take approximately 3 weeks to cover the distance of 384,400 km to the Moon, deep space missions to Mars, a distance of 225 million km, and Lagrangian point 1, a distance of 1.5 million km, require several months of travel, around 11 months for Mars and 4 months for L1. Due to the longer distances involved, trajectory correction plans are incorporated into the mission, utilizing orbit determination calculations to ensure the spacecraft stays on course. During the Mars orbiter mission conducted by ISRO between November 5, 2013 and September 24, 2014, 3 TCMs were carried out on November 14, 2013, June 11, 2014 and September 22, 2014. What are trajectory correction maneuvers? The Aditya L1 spacecraft will be inserted into an orbit around L1. In order to achieve this, the spacecraft must follow a planned trajectory. After the trans-Lagrangian point 1 insertion maneuver on September 19, scientists discovered potential trajectory errors that needed correction. There is a provision in the mission for this type of maneuver, which is known as a trim maneuver, explained former ISRO scientist M. Annadurai, who was closely involved with the Chandrayaan-1 and Mars orbiter mission. This has been part of the mission plan since Chandrayaan-1 2008. For every orbit raising maneuver, we assess the realized orbit. If any adjustments are required, they must be made as soon as possible. For closer destinations like the Moon, trajectory corrections must be made within a week, while for longer destinations, correction should be made as early as possible. Aditya L1 is embarking on a long journey. If there is a side deviation at the beginning, it would have implications over a month or 3 months, the ISRO scientist stated. Smaller corrections involve firing the spacecraft's engines for shorter durations, which helps conserve fuel. Larger corrections, on the other hand, require longer engine firings. We need to assess the extent of the correction needed. It's somewhat similar to assessing how much fuel you need to fill a car, added Annadurai. What is the desired orbit around the L1 point for Aditya L1? When Aditya L1 arrives at the L1 point in the second week of January 2024, it will perform a maneuver to allow it to orbit around L1. L1 is a balanced gravitational location between the Earth and the Sun. During its mission, Aditya L1 will orbit irregularly in a shape roughly perpendicular to the line connecting the Earth and the Sun, according to ISRO. The L1 orbit presents unique challenges in terms of acquisition and maintenance for spacecraft. Unlike orbits around planetary bodies, the L1 orbit is three-dimensional, influenced by the gravitational forces of both the Earth and the Sun. This gravitational interplay requires careful navigation, often necessitating course corrections through the firing of engines. The need for these corrections becomes particularly evident during deep space missions, as evidenced by the experience of the Mars orbiter mission undertaken by ISRO.
In this mission, 3 trajectory correction maneuvers, that is TCMs, were performed to ensure that the Mars orbiter reached its intended distance of 500 km with a tolerance of plus or minus 60 km from the red planet. Without these TCMs, the spacecraft would have deviated, reaching a periapsis distance of 723 km. In summary, the L1 orbit demands vigilance and precision in maintaining the desired trajectory for successful deep space missions. The TCMs carried out by ISRO during the Mars orbiter mission exemplify the critical role of course corrections in ensuring mission objectives are achieved. Thank you for watching 4sidestv with me, Anjali.